All right, let's dive into this world of machine learning,
Okay,
where computers learn to make decisions from data.
right.
It's like teaching a computer to think,
Yeah,
and there are two main ways we do it: supervised and unsupervised learning.
that's a great way to put it, teaching a computer to think.
Yeah.
In supervised learning, it's like we're giving the computer a textbook and a teacher.
So walk me through this textbook and teacher approach.
Sure,
What's
yeah.
actually happening?
Well, imagine training an algorithm to identify different types of flowers.
Wait.
In supervised learning, we'd feed the algorithm a bunch of images.
Okay.
Each clearly labeled with the flower's name: rose, tulip, sunflower, you name it.
Mm-hmm.
That labeled data is the textbook.
Okay, so the algorithm is essentially reading these labeled images.
Right.
What role does the teacher play?
The teacher is the part of the algorithm that provides feedback.
Okay.
It compares the algorithm's predictions like, I think this is a rose, to the actual labels. If the algorithm gets it wrong, the teacher adjusts the algorithm's parameters,
Okay.
helping it learn from its mistakes.
So it's like the algorithm is doing practice problems
Yeah.
and getting graded.
Exactly.
And with enough practice, it starts to get pretty good at identifying those flowers.
Exactly. The algorithm starts to pick up on subtle patterns, the shape of the petals, the arrangement of the leaves features that we might not even consciously notice.
That's fascinating.
Yeah.
So once the algorithm is trained,
Right.
you could show it a picture of a flower it's never seen before.
Yep.
And it could probably tell you what kind of flower it is.
Right. That's the power of supervised learning.
Wow.
And this approach isn't limited to flower identification. It's used in all sorts of applications.
Oh, cool.
Think about predicting house prices, filtering spam emails, or even personalizing online shopping recommendations.
It's all starting to click now.
Good.
But what about unsupervised learning?
Yeah.
Does that involve ditching the textbook and the
Mhm.
teacher?
Exactly. In unsupervised learning, we're giving the computer a giant puzzle with no picture on the box.
Okay.
We're providing data, but no labels or predefined categories.
Gotcha.
The algorithm has to figure out the patterns and relationships on its own.
So it's like we're saying, here's a bunch of data, go explore and see what you can find.
Yeah.
But how does an algorithm even begin to make sense of all that unlabeled information?
That's where things get really interesting.
Okay.
One common technique in unsupervised learning is called clustering.
Okay.
Imagine a music streaming service wants to understand its users' listening habits better.
Okay.
They have data on which songs people listen to, how often, and at what time of day.
Okay, so they have all this data,
Right.
but no predefined categories like rock fans or pop enthusiasts.
Right, so they unleash an unsupervised learning algorithm.
Okay.
And the algorithm might discover that a certain group of users consistently listens to energetic, upbeat music on their morning commutes.
So the algorithm is essentially saying, hey, there's a pattern here. This group seems to like high-energy music in the morning.
Exactly.
And maybe the streaming service could use that information to create a morning commute pump-up playlist.
Precisely, it's all about uncovering those hidden gems of insight within the data insights that we might not have even known to look for.
That's pretty incredible.
Yeah.
So it sounds like unsupervised learning is great for tasks where we don't have clear categories or predefined answers.
You got it.
Okay.
And this type of learning is used in a ton of applications, from grouping customers with similar purchasing habits to detecting anomalies in financial transactions.
All right, so we have supervised learning the student with a textbook and teacher,
Right.
and unsupervised learning the explorer, venturing into uncharted data territory.
Yes.
But before we dive deeper into those applications, I'm curious about the key differences between these two approaches.
Sure.
What makes them unique?
At the heart of it, the key difference is the type of data we feed the algorithms. Supervised learning thrives on labeled data, where each input has a known output.
Okay.
It's all about making predictions based on those known patterns.
Whereas unsupervised learning operates on unlabeled data,
Exactly.
allowing the algorithm to discover its own patterns and relationships.
Exactly. And because of this fundamental difference, supervised and unsupervised learning have unique strengths and are suited for different types of problems.
I'm starting to see the bigger picture now.
Good.
So if we want to predict a specific outcome, like whether a customer will click on an ad, supervised learning would be the way to go.
That's a great example.
Yeah.
And if we want to uncover hidden groups or patterns within a data set, unsupervised learning would be the tool of choice.
This is all so fascinating.
Yeah.
I can't wait to explore how these methods are used in real-world applications.
Me too. There are some truly mind-blowing examples out there.
Well, before we jump into those, let's pause here for a moment.
Okay.
We've covered a lot of ground,
Yeah.
and I want to make sure everything is crystal clear for our listeners.
Absolutely. It's always good to take a step back and ensure we're all on the same page.
So just to recap,
Okay.
supervised learning is about learning from labeled data,
Right?
making predictions, and having a teacher guide the process.
Right.
Unsupervised learning is about exploring unlabeled data,
Yes.
discovering hidden patterns, and letting the algorithm make its own connections.
That's a perfect summary.
Okay, cool.
And with those core concepts in mind, we're ready to dive into the amazing ways these techniques are shaping our world.
Awesome.
Yeah, it's amazing to think about how these algorithms can learn from data, almost like a student studying for a test.
It really is. And speaking of learning, I'm curious about how these techniques, supervised and unsupervised learning, work with other concepts in AI,
Okay.
like deep learning. I hear that term thrown around a lot,
Hmm.
but I'm not quite sure I understand it.
That's a great question. Deep learning is essentially a subset of machine learning that uses artificial neural networks, which are inspired by the structure of the human brain.
Neural networks that sound incredibly complex.
They can be, but the basic idea is that they're made up of layers of interconnected nodes that process information. Think of it like a network of neurons passing signals back and forth.
Okay, I'm starting to get the picture, but how do these neural networks fit into the whole supervised and unsupervised learning thing?
Well, the cool thing is that they can be used in both.
Oh, wow.
For example, in supervised learning, a deep neural network can be trained to recognize images with incredible accuracy.
So instead of just identifying basic shapes or colors, a deep neural network can actually understand the content of an image, like telling the difference between a cat and a dog,
Right.
even if they're both furry and have 4 legs.
Exactly. Deep learning allows these algorithms to learn much more complex patterns and relationships within the data.
That's mind-blowing. It sounds like deep learning is taking image recognition to a whole new level.
Yeah.
What about unsupervised learning?
Yeah,
Can deep neural networks be used there too?
absolutely. They're actually revolutionizing unsupervised learning. For example, in the field of natural language processing, deep neural networks are being used to understand and generate human language in ways we never thought possible.
So you're saying that a computer could potentially write a poem or even a novel using deep learning?
It's not quite that simple,
Okay.
but we're getting closer. Deep neural networks are being used to translate languages, summarize text, and even compose music. The possibilities are truly expanding every day.
It sounds like deep learning is pushing the boundaries of what's possible with both supervised and unsupervised learning.
It certainly is. And as these technologies continue to advance, we can expect even more groundbreaking applications in fields like healthcare, finance, and transportation.
Okay, before we get ahead of ourselves and start imagining a world run by AI novelists and composers, let's take a step back and recap the key differences between supervised and unsupervised learning.
Good idea. Sometimes it's helpful to go back to basics to make sure everything is crystal clear.
So to summarize, supervised learning is like having a teacher guiding the algorithm with labeled data.
Right.
It's all about making predictions based on known patterns. Like if we feed an algorithm a bunch of labeled images of cats and dogs, it can learn to predict whether a new image is a cat or a dog.
Precisely. And unsupervised learning is more like an explorer venturing into unlabeled data to uncover hidden structures and relationships. For instance, if we give an algorithm data about customer purchases, it can cluster those customers into groups based on their buying habits, even without any predefined categories.
Right, and we saw how these two approaches can be combined with deep learning using neural networks to achieve even more sophisticated results.
Exactly. It's like we're giving these algorithms a more powerful brain to work with.
This is all incredibly fascinating.
Yeah.
But I also wonder about the practical implications.
All
Are
right.
there any downsides or limitations to these approaches?
That's a great point. It's important to remember that these are tools, and like any tool, they have their limitations. One thing to consider is that the quality of the data we feed these algorithms is crucial.
So if we train a supervised learning algorithm on biased data,
Yeah,
the results will also be biased.
exactly. And in unsupervised learning, if the data is noisy or incomplete, the algorithm may struggle to find meaningful patterns.
It sounds like data quality is the foundation of successful machine learning.
Absolutely. And another thing to consider is that these algorithms can be computationally expensive to train, especially when dealing with large data sets.
So there are practical challenges to consider as well. It's not just a matter of plugging in some data and letting the algorithms work their magic.
Exactly. It requires careful planning, data preparation, and ongoing monitoring to ensure that these algorithms are used effectively and responsibly.
This all makes perfect sense.
Mm-hmm.
It's a good reminder that even with these powerful technologies, human expertise and judgment are still essential.
Couldn't agree more. We need to understand the strengths and limitations of these tools to use them effectively.
It feels like we've only just scratched the surface of what's possible with machine learning. Are there any other approaches or variations that we haven't touched on yet?
You're right, there's always more to explore. One area that's really fascinating is semi-supervised learning.
Okay.
It's like a hybrid approach that combines elements of both supervised and unsupervised learning.
Semi-supervised learning, that sounds intriguing. It's like a middle ground between having a teacher and exploring on your own.
Exactly. Imagine a scenario where you have a small amount of labeled data,
Okay.
like images of cats and dogs with their correct labels,
Uh-huh.
but you also have a much larger set of unlabeled images.
Okay, so we have a limited textbook, but a vast uncharted territory of data.
Right.
How does semi-supervised learning approach this?
Well, the algorithm uses the labeled data as a starting point. Like a
Okay.
set of initial clues, it learns some basic patterns from those labeled examples.
So it's like getting a glimpse of the puzzle box to get a sense of what we're looking for.
Precisely then, the algorithm uses those initial insights to make sense of the unlabeled data.
Okay.
It tries to group similar images together, even if they don't have labels.
So it's like the algorithm is saying, okay, based on what I've learned from these labeled images, I think these unlabeled images also belong to the cat group, and these ones probably belong to the dog group.
You got it. And as it explores the unlabeled data, it refines its understanding of the patterns and relationships, becoming more accurate in its predictions.
That's a really clever approach. It seems like semi-supervised learning could be especially useful in situations where labeled data is scarce or expensive to obtain.
Absolutely. Think about medical imaging, for example. It can be very time-consuming and costly to have experts label every single image.
Oh, that's true.
Semi-supervised learning allows us to leverage a smaller set of labeled data and still achieve high accuracy in diagnosing conditions.
That's incredible. It feels like machine learning is constantly evolving, pushing the boundaries of what's possible.
It certainly is, and as these algorithms become more sophisticated, they're being integrated into more and more aspects of our lives.
From personalized recommendations to self-driving cars, it's amazing to see how machine learning is shaping the world around us.
It's a truly exciting time to be working in this field, but it's also important to remember that these are powerful tools that should be used responsibly.
That's a good point. As we embrace these advancements, we need to be mindful of the ethical implications and ensure that these technologies are used for good.
Absolutely. We need to consider potential biases in the data, ensure privacy and security, and promote transparency in how these algorithms are developed and deployed.
It's a reminder that while machine learning has immense potential, it's up to us to guide its development and use it in a way that benefits humanity.
Well said. It's an ongoing conversation and a shared responsibility.
This has been an incredibly insightful journey into the world of machine learning. I feel like I have a much deeper understanding of these approaches and their impact on our lives.
It's been a pleasure exploring these topics with you, and I hope our listeners feel empowered to continue learning and engaging with the ever-evolving field of AI.
Absolutely. Remember, the future of AI is not predetermined. It's a future that we are all actively shaping with our choices and our commitment to responsible innovation.
Here's to a future where machine learning empowers us to solve complex problems, create new possibilities, and build a better world for everyone.
That's a fantastic note to end on. Thanks for joining us on this exploration of machine learning. Until next time, stay curious.